Okay, so in the previous video, we looked at electric current and potential difference. Here, we're going to look at resistance. So, what is resistance? Resistance is the opposition to the flow of current through a conductor in an electric circuit. It is the opposition. Opposition means to draw back, right? So, we can say that resistance is the drawback to the flow of electric current through a conductor in an electric circuit. Resistance is measured in ohms, and this is the symbol for ohms, right? So resistance is very important. It is very important. It is the opposition to the flow of electric current through a conductor in an electric circuit. If you take, for instance, this cell phone, the current that flows from the socket into the phone does not flow directly, right? It's not all the amount of current that flows into it. It is being downregulated. It is being opposed by resistors that are present the in the charger and also in the phone, because it's not all the current that goes to all parts of the circuit in this phone, right? So that opposition, that drawback to the flow of electric current is what resistance is all about. It is very important. It is important in many ways, in the sense that it helps to draw back current, and also it helps to prevent overheating in electric circuits. It helps to prevent overheating in electric circuits and other appliances, because too much of current, too much of the supply of current into a circuit can lead to overheating. So that is prevented. And also it controls the voltage that is being supplied into this phone, right? So it's very important. Again, resistance is the opposition to the flow of electric current through a conductor in an electric circuit. And like I said, it is measured in ohms. So the material that offers resistance is called a resistor. So inside every circuit, you have a resistor. Inside all appliances, you have a resistor, because current has to be opposed. So this is a symbol for resistance in an electric circuit. So whenever you see an electric circuit and you see this symbol, or you see this symbol, this is what resistance. So resistance can be in this form, or it can also be in this form. This is the symbol for it. Then the factors that affect resistance, there are four major factors that affect the resistance of a conductor. They are basically temperature, cross-sectional area, length of the conductor, and resistivity. So note these four factors. We're still going to look at them in another video. So before we move further, it's very important that you should know that there is a formula that connects the second factor, the third, and the fourth factor. And that is resistance of a material is equal to the resistivity times the length all over the area of the conductor. So this formula is very important. It's very important. R, which is resistance, is equal to resistivity times length over the area of the conductor, right? So note this formula and note these four factors as well. So having known this, there is a law that guides the resistance of a conductor in an electric circuit, and that is Ohm's law, right? So Ohm's law states that the current flowing through a conductor, it states that the current flowing through a conductor between 2 points is directly proportional. So is directly proportional to the potential difference across the 2 points, provided the temperature and other physical conditions remains constant. So the other physical conditions they're referring to here are the cross-sectional area, the length of the conductor, and the resistivity. So provided these factors remains constant, electric current flowing through a conductor in an electric circuit is directly proportional to what? The potential difference, which is what? V. So again, Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the potential difference across the 2 points, provided the temperature and other physical conditions remains constant. So Ohm's law is trying to say that the current flowing through a conductor between 2 points is directly proportional to what? The potential difference across the 2 points, provided the temperature and other physical conditions remain constant. So to remove this sign of proportionality, what we'll do is to bring in a constant. So my I, electric current, will be equal to kV, where K, which is the constant, K is equal to 1 all over what? R. So this is a value for K. So if K is equal to 1 all over R, that means my I, which is electric current, is equal to 1 all over R, which is this K, times what? V. So 1 times V will give us what? V. So this will be equal to I, this will give us I is equal to V all over what? R. So this formula is very, very important. It's very, very important from Ohm's law. I is equal to V all over what? R. So where I is the electric current, V is the potential difference, and R is what? The resistance. So like I said, Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the potential difference between the 2 points, provided the temperature and other physical conditions of the conductor remains constant. So from Ohm's law, you have that your I current is directly proportional to what? Your potential difference. So to remove the sign of proportionality, like I said, we have to bring in a constant. So I will be equal to what? Kv, where K is our constant, right? So I is equal to Kv. K is equal to 1 all over what? R. So if K is equal to 1 all over R, if I put the value of this K, if I put the value of K, which is 1 all over R here, what I'm going to have is I is equal to 1 times V over what? R. Because K is equal to what? 1 over R. So if I multiply this, 1 times V will give us what? V, right? So this will be I is equal to V all over R. So this formula is very important, and it is derived from Ohm's law, right? So if I should make this V the subject of the formula, this will be like I all over 1. I divided by 1 will still give us I. So V times 1 will give us V. So V is equal to I times R will give us what? IR, right? So this formula is also very important. It is derived from Ohm's law. So V is our potential difference, I is the electric current, and R is what? The resistance. So whenever we are doing calculations that pertains to potential difference, resistance, and electric current, this is what we use. Right, so let's look at some questions. A 12-volt battery is connected to a 4 ohm resistor. What is the current flowing through the resistor? A 12-volt battery, what does that tell you? That tells you that the potential difference V is equal to what? 12 volts. So a 12-volt battery is connected to a 4 ohm resistor. What does that tell you? That the resistance is equal to 4 ohms. What is the current flowing through the resistor? So what you're asked to look for is the current that is flowing through the resistor, which is what you don't know. So with these parameters that are given to you, what is the relationship that connects V, R, and I? Well, the formula that connects it is V is equal to IR from Ohm's law. V is equal to IR. So if I should make I the subject of my formula, I will have to divide both sides by the coefficient of R, which is what? By the coefficient of I, which is R. So this will be V over R is equal to IR over R, where R will cancel at R. So my V over R will be equal to what? I. So my I will be equal to V over R. This and this are the same, right? And this is what we even got from Ohm's law, that I is equal to V over R, right? So if I is equal to V over R, my V is what in this question is 12. So my I is equal to 12 over, my R is what? 4. 12 over 4. So 12 divided by 4 will be equal to 3. So my I will be equal to 3 ampere. So this is very important. 3 ampere. This is my answer, right? So just a quick recap. Current is measured in what? In ampere. In ampere. Potential difference is measured in volts, while resistance is measured in what? In ohms, right? So my current here is equal to what? 3 ampere. Let's look at the next question that we have. A 5 ohm resistor has a current of 2 ampere flowing through it. What is the potential difference across it? A 5 ohm resistor, what does that tell you? It tells you that the resistance is equal to what? 5 ohms, has a current of 12 ampere. So the current I is equal to 2 ampere, sorry. It has a current of 2 ampere flowing through it. What is the potential difference across it? So what we're looking for here is the potential difference, which is measured in volts, right? So what is the formula that connects resistance, electric current, and volts? It is V is equal to what? IR. So my V will be equal to, my I is 2 ampere times my resistance is what? 5 ohms. So 2 times 5 would be 10, right? So my potential difference will be equal to 10 volts. This is the answer. It's very easy and straightforward. So let's look at the last example or question that we're going to look at in this video. A heater draws 5 ampere from a 230 volts. What is the resistance of the heater? So the first thing we're going to do is to bring out the parameters, right? So a heater draws 5 ampere. So the current, that tells you current, 5 ampere. So the current is equal to what? 5 ampere from a 230 volt supply. That tells us that the potential difference is equal to 230 volts. What is the resistance of the heater? So what we're looking for is the resistance of the heater. So the formula that connects electric current, volt, and resistance is V is equal to IR. So what we're looking for is the arrow. So we have to make arrow the subject of the formula here. So by making arrow the subject of the formula, I will have to divide both sides of the equation by the coefficient of arrow, which is I. So this will give me V over I is equal to arrow, I arrow over what? I. Where my I here will cancel I here. So my V over I will be equal to what? R. So my R will be equal to V over I. This and this are the same. So if this and this are the same, my R will be equal to, my V is what? 230 volts. That's 230 over, my I is 5 ampere. 5. So 230 divided by 5 will be what? So my R will be equal to, I'll bring out my calculator and then punch 230 divided by 5. That will be equal to 46. So 230 divided by 5 is equal to 46 what? Ohms. This is the answer to this question. So this is actually very important. The main thing that you should know here, know what resistance is. That resistance is the opposition to the flow of electric current through a conductor, an electric circuit, and the factors that affect resistance: temperature, cross-sectional area, length of the conductor, and resistivity. So let's look at one more other question. Which of the following factors does not affect the resistance of a conductor? So the factors that affect the resistance of a conductor, there are 4. We have temperature, we have length of the material of the conductor, we have resistivity of the material, and then lastly we have the cross sectional area. So option A, I have length of the conductor, it's a factor. Temperature of the conductor, it's a factor. Color of the conductor. So color is of the conductor is not a factor that affects the resistance of the conductor. So this is our correct answer. Is not, does not. So it's a factor that does not affect the resistance of a conductor. So lastly, if the length of a wire is doubled and its cross-sectional area remains the same, what happens to the resistance? A, it remains the same. B, it doubles, C, it halves. Then D, it becomes 4 times. So, like I said before, the formula that connects resistance and the factors that affect resistance is R is equal to resistivity times length all over what? A. So this formula, like I said, is very important. Resistance is equal to resistivity times length over A. So if the length of a wire is doubled, if the length L is doubled and its cross-sectional area remains the same and the area remains the same, that's the area is not changing, what happens to the resistance? So you can see that resistance is directly proportional to what? To L, to the length. So what that means is that as the length is increasing, resistance will also be increasing. Resistance increasing, the length is increasing. Length is increasing, resistance is increasing. So that's the direct proportionality. So if the length of a wire is doubled and its cross-sectional area remains the same and the cross-sectional area remains the same, what happens to the resistance? The resistance will also double. So the correct answer to this question is B, option B. It doubles because they are directly what? Proportional. So with this, we come to the end of this video. Thank you very much for paying proper attention.